All right, hey everybody. So today I'm home again because I have a couple of doctor's appointments and I wanted to get those out of the way. Sorry, I know this comes at a very bad time, but I'm going to make sure that you're not behind on your notes, okay? So we're going to continue where we left off on Friday. I left off right here at offshore drilling and our floating oil production platform in the Gulf of Mexico. So this is where I want to start. Make sure that you have something to take notes with out on your desk. We're going to go over the last little bit of fossil fuels, and then we're going to go straight into nuclear power today. So I have a couple of things that I have in Canvas for you as well, and I'll mention them as we go through. All right, let you get set up real fast. I hope y'all had a great weekend. Whew. And let's go ahead and get started. All right. So now, the environmental impacts of oil and natural gas. First of all, we talked before about the environmental impacts of coal. Now, with oil and natural gas, the power production of oil and natural gas is very similar to that of coal, as you should have seen in the video that I had y'all watch over the weekend. I'm assuming you did watch that. Maybe some of you had a little party to watch it because I only saw about 11 watches on my YouTube video. So either that means you had a group viewing or some of you didn't do your homework. So please make sure that you watch that. Basically, you have combustion of this fossil fuel. Remember, this is organic products made in the earth that can be burned, all right? So they're burned in that chamber in the power plant, and then that burning will produce emissions through that smokestack, okay? It's basically, number one, going to produce carbon dioxide. That's the big one. And then other toxic pollutant emissions. So it's going to increase the amount of carbon dioxide in our atmosphere, which is a greenhouse gas. And we'll talk more about that in our next unit. Natural gas is a far cleaner burning fuel than oil. It has a lower amount of carbon dioxide being put up into the atmosphere and a lower amount of other kinds of gases. So lower sulfur, lower nitrogen, all of that. It does produce a disturbance to the land and habitat. All of that drilling will produce lots of disturbance. Number one, the exploration itself produces disturbance. So in geologic exploration, you have GPR, which is ground penetrating radar, which can look into the layers of the earth using radar. It doesn't really disturb anything down into the earth, but you have to have a large vehicle or a large area where you can use a thumper. And anybody who has seen Dune is probably giggling right now, but yes, it's called a thumper. And it actually makes an impact on the earth and produces sound waves, which reverberate down into the earth, and we time how long it takes for them to come back. And when we were able to actually see kind of like an echo location of what is going on under the earth. And based on that, we can determine the composition and the thicknesses of the different layers down there. And that also will tell us what kind of formations are down there. So is it solid? Is it liquid? Is it gas? So that kind of exploration is going to need a large area of flat land. All right. So sometimes that involves cutting down trees. Sometimes that involves accessing land that would not normally be accessed. So going on to preserves, national wildlife preserves, and other kinds of areas. And sometimes it's marine areas. And it's hard to figure out what's going on all the way down at the bottom of the ocean. Once you do get permission to do the drilling, then you've got a whole nother kind of disturbance to the habitat, because you're drilling, making a big hole down into the earth. And it's not just the drilling process, but it's also things that make drilling possible. So lubrication and other kinds of water and chemicals that make the drilling able to actually happen. So transport of the actual crude oil and natural gas once it is excavated. So spills can happen, especially in aquatic systems, because you not only have to get it out of the solid crust of the earth, but you have to get it up through the water column. Okay, so that is especially very, very fragile. And so there are lots of examples of things that can happen that we can point to. For example, the Alaskan oil spill, okay, Exxon Valdez in 1989 is one of the two largest oil disasters in oceans that we can talk about here. So let's point to a couple of these. All right, so first I'm going to talk about one that's a little bit closer to home. This one, Deepwater Horizon. You probably have heard of this a lot more than the Exxon Valdez oil spill, because this probably happened within your lifetime. So April 22nd, 2010, Deepwater Horizon was a drilling platform, just like the one that we looked at just a little while ago in the Gulf of Mexico, and it exploded. So this was not something that happened in transport. This was, they were actually actively drilling, and drilling was happening down in the Gulf of Mexico, and then an accident happened, an explosion happened on the platform while drilling was happening. So the oil from the oil well continued to flow out of the drilling hole. Okay, so they were drilling, the explosion happened, and it just gushed completely out of there through that straw hole. And it was directly from the crust of the earth down in that marine area into the Gulf of Mexico. All right. So this was not from a barge or anything like that. This was completely just from the earth into the Gulf of Mexico. Okay. So the flow of oil from the oil well, it flowed for months. Okay, April to mid-July of 2010. It's estimated that about 5 million barrels of oil flowed into the ocean, and because oil is less dense than water, then especially salt water here, then most of it rose to the surface, and then it spread out into the Gulf of Mexico. So this affected that entire marine habitat, so fish, algae, everything. It became an area that was basically a dead zone. So marine birds, like the one that you see here, and they tried to contain it with booms, floating barriers to contain the spill, but a lot of it was just uncontainable. So here's this extent of the Deepwater Horizon spill. Okay, so here's the location, but most of this is going onshore at this point, because it's not out in the middle of the ocean. This is fairly close to shore. All right, so you've got all of these locations. Here is Gulfport, here's Mobile, Alabama, you've got Pensacola, you've got all of these areas over in Louisiana. So all of these coastal areas were highly affected, and you just had huge areas of oil that would just wash up on the shore. Okay, and the trajectory of the oil was going straight onshore, just right over here. Okay. All right, so this compared with the 1989 Alaskan oil spill. So this was different because this was oil that had already been collected. This was not in the middle of a drilling process. This was crude oil that had already been harvested from a drilling rig, and it was being transported by the Exxon Valdez barge. All right. So it was going up into Prince William Sound, which is up in Alaska. I'll show you a map in a minute. And it hit a reef. Okay. It went off course and hit a reef, and it spilled 260,000 barrels of crude oil into Prince William Sound. So compare this, all right, 260,000 barrels of crude oil with the 5 million barrels of oil, okay? Now this is because this was a oil well that just continually flowed into the Gulf of Mexico. That's why they say, hey, this was more of a disaster right here, okay? But I want you to know, oil seeps into the ocean all the time through cracks and stuff. Not like this, though. Not 5 million barrels of it. Not at all, okay? That's a huge amount more. Exxon Valdez was only 260,000 barrels. But 260,000 is a whole heck of a lot more than it should be. So this was the largest oil spill in U.S. history, okay? So we say spill because it was in a boat or a barge and it spilled into the ocean. This was a disaster. This was a spill. You see the difference? Okay, so now this led to the Oil Pollution Act of 1990, where we try to regulate how much gets transported at a certain time and where it gets transported. Also, who gets to be in charge. And I'll talk to you about why in just a minute. This is these are some of the people trying to clean up the shorelines. A lot of the shorelines in Alaska are rocky, okay? They don't look like regular beaches. They're just a whole bunch of large rocks along the shore because they're glacial beaches, all right? A lot of glacial till right along here. And so all of these were probably white before, okay? White or very light gray. Now they're black because they're covered in oil, all right? Okay, so here is the oil spill from above. All the shiny spots, that's all oil, okay? And right here, this is Prince William Sound, okay? So this is where it spilled. So it went in here and ran into a reef right in here in this area, and the oil actually spread all the way down through here. So you see oil from this spill all the way down through Kodiak Island and along the Aleutian Islands of Alaska from this. So It's and you're still seeing evidence of that today. So I mean, I used to hear about it all the time, and people would still be talking about how there's still cleanup going on. But the kind of cleanup in '89, the kind of cleanup that they would do was Dawn dishwashing soap. That was the big thing. They would go and wipe the birds down with Dawn dishwashing soap and paper towels. That's all they could use, because anything else would just spread the oil even further, or wouldn't take the oil off. Okay, because think of oil is nonpolar. Okay, and it needs to be wiped off of something. It's not going to combine with anything else in order to make a solution to be washed off of something. Okay, it's not going to combine with water. It needs to be wiped off, and so it's a huge problem, right? So this is another thing that I wanted to point out to y'all in terms of disturbing natural areas in search of petroleum or natural gas. A couple of the things that are in dispute right now are the National Petroleum Reserve in Alaska and the Arctic National Wildlife Refuge, ANWR. If you ever see this acronym right here, ANWR, that is what they're talking about right here. Okay, there's a Trans-Alaska pipeline that comes all the way down here from the north of Alaska. This is called the North Slope in Prudhoe Bay, and a lot, I mean a ton of the oil that is our own here in the United States comes right up here in Prudhoe Bay. Okay, and then we have a huge National Petroleum Reserve up here, and then there's a lot more that has been found, and they say that a lot of the petroleum companies want to go and drill for more here in the Arctic National Wildlife Refuge, but we're trying to keep this as a wildlife refuge and prevent more drilling from occurring, more new drilling from occurring, because it's a preserve. It's something that would disturb natural ecosystems and habitats with anything like that. I mean, think of all of the different things that could happen when you have GPR or you have other exploration techniques and drilling and fracking and everything going on in there. So, all right, let me take a breath for a second. Yep, that's it. Okay, I'm going to take a breath, and then I'm going to switch to nuclear. So, switch in your notes if you need to. All right. One other thing that I wanted to mention, I'm going to put in Canvas a couple of short videos on both the Deepwater Horizon and the Exxon Valdez, in case you're interested. They won't be long. It's just something that I usually put in there because those are very interesting. They are there's something that you should know about. You should know about those two. All right. So just like you should know about Chernobyl or Fukushima, like we're going to talk about here in a second. All right. So let's look at nuclear energy. All right. Nuclear. So if you watched my video talking about power plants, you should know these cooling towers right here are just cooling towers. And these emissions coming out of them are what? I hope that you are saying steam, H2O. Okay? Are they radioactive? No, not at all. Is what you're saying in class, even though I'm not there? No. These are just cooling towers, okay? So nothing radioactive about them. It's just water vapor. And so there's a lot of misconceptions about nuclear energy that I want to make sure that we clear up today, if you have any. But yes, there are hazards with this, okay? There's trade-offs. There's the good and the bad. So let's jump in. Nuclear energy. That's the release of energy due to fusion or fission, okay? And this is the key right here. It involves the changes in the nuclei of atoms. That's why it's called nuclear, all right? Changes in the nuclei of atoms. Hopefully, you remember this from chemistry. Maybe. If you don't, then you're getting a refresher course right now. All right, so the difference between these two processes. Fission. Fission is division. If you heard somebody say that before, I'm bringing it back, okay? Fission. Larger atoms split into two smaller atoms of different elements. So it starts out as one element, and then when fission occurs, it splits and it becomes a different, smaller element. All right? When this happens, a huge amount of energy is produced. So, this is what we do when we have a nuclear power plant. Nuclear energy produced at a power plant. We're doing fission. All right? You might want to make a little note at the side or something like that saying, hey, this is what we're doing. Fission. Okay. Fusion, on the other hand. I used to have fusible webbing when I was sewing things. I don't know if anybody in here sews, but fusible webbing fuses things together, okay? Fusion is two smaller atoms combining or coming together to make a larger atom of another element. So it's the opposite, okay? So you have two smaller atoms and they merge together and they make a bigger atom that's something else. This happens in the sun. This is the kind of energy that powers the sun. And we wish we could harness this energy. This would be super awesome. Oh my goodness. If we could harness the energy of fusion, we would have so much energy for our power plants, for our houses, for all the different things that we could do. And we're trying. We are so trying. We'll get to this in just a little bit. Okay, so nuclear fission. Here we go. We've got a picture right here. So this fission reaction, like I said, produces an enormous amount of heat. Oh my goodness. So this is, instead of combusting, okay, we use uranium as the fuel for this. But instead of burning it, we're going to start a nuclear fission reaction with the uranium, okay? And that reaction is going to produce heat. And that heat is going to heat up the water and produce steam. There you go, okay? That's what we were talking about before. So here, we've got uranium-235, all right? We're going to bombard it with free neutrons. Here's a neutron, and we're going to say, hey, neutron, go and hit it. Boom, okay? When the neutron hits the uranium, then it splits, okay? The uranium will split into two smaller atoms, okay? So neutron hits uranium, and then your products are going to be smaller atom right here, smaller atom right here, and then more free neutrons. And so it's like a chain reaction. So now you've got more free neutrons to go and hit another uranium atom, which then splits into more smaller atom, and more free neutrons, which can then go and hit more uranium. Boom, 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 boom. This, if we let this keep going, it's going to go out of control. Okay? Because every time this happens and we have a new fission with new smaller atoms, this produces not just the smaller atoms and free neutrons, but also heat. Boom, heat. Boom, heat. Boom, heat. All right? Each time. So if we keep on having free neutrons out here, it's going to keep on hitting those uranium atoms and producing more heat. Okay? That's why we have to have a way to control this reaction. All right. So, pros and cons. Okay, good part. We have a much less of an immediate environmental impact compared to fossil fuels, okay? So, basically, in this power plant, we're not putting any kind of atmospheric pollution into our environment, okay? Carbon-free source of energy. We're going to put this in quotes. All right, here's quotation marks. Quotation marks. All right, carbon-free, because there's no carbon dioxide going into the atmosphere. Hooray, okay? However, how do we get our uranium to the power plant? Fossil fuels, okay? How do we mine it? Using equipment that uses fossil fuels, okay? So that's why we go carbon-free in quotation marks. But that's less of an immediate environmental impact. There we go, all right? So that's what we're talking about there. The only thing that the power plant gives off immediately is that water vapor, because we can recycle that water over and over again until it becomes less usable, and then we let it evaporate in the cooling tower. Now, cons. Does generate radioactive waste, because after our uranium fission reaction happens, then we have a radioactive byproduct. Okay? We also have other kinds of radioactive waste because they have touched or they have been in contact with this fission reaction. Like I said, many steps require the fossil fuel, okay? And it's expensive, all right? The mining is expensive. The encapsulation of everything to make sure that the reaction doesn't get out of control is expensive. All of this stuff costs money, Okay, now, safety. When people think of nuclear, a lot of times they think, hey, is this safe? Well, a lot of times it actually is pretty safe. So nuclear reactors are not nuclear bombs. All right, I want to get that out of the way. They are not. They don't produce a bomb-like explosion. But the other dangers come in forms of meltdowns. All right? So if that fission reaction goes out of control, like I talked about before, it can produce such a high temperature that the metal or the concrete encasing that fuel can melt, and then the radiation gets released. And this is what happens a lot of times when you see the stories of nuclear reactor disasters. Now, a lot of times these accident probabilities are low. In fact, we only have stories of nuclear power plant disasters very, very few times. I mean, I can think of less than 10, maybe even less than 5 in my mind. But public perception of the risk is high because people think of nuclear bombs and people distrust the nuclear industry. So the other thing is, when there is a hazard or when there is a disaster, they're horrible. Okay? So they're catastrophic. It's so bad that people don't want even the possibility of something like that happening. So like I said over here, the hazards are potentially catastrophic. Both the short and the long-term consequences are life-altering. Okay, so the first one I want to talk about here, 3 Mile Island. This is probably what we would call the United States nuclear disaster. This is the only one that we've really had, and it happened in 1979 in Pennsylvania. Basically, this came down to human error, all right? Some design errors also, but this was mainly somebody who was not doing their job, okay? And it produced a partial meltdown. So the encapsulation of the nuclear reactor partially melted down and opened so that the radiation leaked out. But the containment building was able to keep almost all of the radiation from escaping, and there were no casualties. So that's why, I mean, we can say, hey, yes, there was technically a meltdown. We did have some radiation leakage, and we can chalk this up to a disaster occurring. But this one was something that we can learn from and look to and say, hey, it could have been so much worse. So much worse. And this is the one that we had in the United States. So definitely want you to know that. Okay, Chernobyl is the one that we would say is the worst nuclear power plant accident ever. Okay. Man. Well, what to say about this? Okay, so you need to know when it happened, where it happened, and basically what's happened since. So 1986, former Soviet Union, in the Ukraine, basically nothing went the way it was supposed to because people were violating safety rules. They weren't doing what they were supposed to be doing. The whole design of the power plant was flawed initially, but the workers were not following the rules in the first place. So they were kind of cutting corners, all right? And there was operator error. The story goes that he wanted to go home early, and he kind of skipped some steps, and it just it's very sad. Okay, so this was pretty much the closest that we've ever seen to a total meltdown. Large amount of radioactive material was released into the atmosphere, and they had to force evacuations in a 30-kilometer radius. So here you can actually see how things have been affected here in Europe. Heavy radioactivity by the red and medium with the orange. And this is just in the atmosphere, okay? So here is where Chernobyl was in the Ukraine, okay? But effects can be seen all the way throughout Europe, all the way down into the Mediterranean, down here by Italy, all the way over into France. And this has to do with atmospheric circulation, okay, whether it's heavy or medium. Over in Great Britain, over by Ireland, up into Sweden and Norway. I mean, it's unpredictable as to how the fallout is going to occur. But in terms of cleanup, the reactor itself had to be encased in concrete. They call it entombed, like a mummy or a pharaoh, but entombed in concrete. The whole area of all of the soil and all of the buildings and everything had to be scrubbed. The soil was removed. And in the years since, so this was in 1986, so it's been over 30 years since, and they've had to replace the entombment, the concrete. They've had to replace it twice since then because the radiation keeps leaking out. Okay, they've detected it leaking out through the concrete. So other effects: decreased agricultural production, no drinkable water or safe produce in parts of Ukraine, nothing. Okay, and people have had cancer. People right there around Chernobyl have had various types of cancer, and the people that worked on the cleanup of Chernobyl, they basically had a death sentence, and it depended on how long they were working on the cleanup as to how long they were going to live. Now you can pay to have a tour. I'm laughing, but I'm kind of morbidly laughing, of the area that it's been safe it's been deemed safe to be around, but you have to wear a radioactivity detector. And it's just so weird. Okay, now, Fukushima. In 2011, I don't know if anybody remembers this or has heard about it, in Japan. I was actually living in Alaska when this one happened, and we were under a tsunami warning when this happened. We had to prepare in case a tsunami hit us because of this earthquake. So the cause of it was an earthquake that measured 9.0. This is almost the highest earthquake, highest Richter scale measurement that we have ever had on record. And this caused a tsunami wave hitting the Japanese coast, and it damaged a nuclear power station. So because of this, it cut out the power supply for the power station and the backup systems that pump the cooling water. That's a bad thing. So the cooling water didn't cool down the reactor and caused an explosion and a core meltdown. Oh my goodness. This was bad. So because of this, they have horrible contamination of groundwater and the ocean surrounding it, and they've had to have an evacuation in a 20-kilometer radius. Now, it's not just their groundwater and their ocean that's been contaminated. I don't know if y'all have read anything about this, but because of our circulating ocean currents, this contaminated ocean water is circulating around the Pacific. So it has come all the way around the Pacific, and it has hit our shores. So let's talk about attitudes toward nuclear power. There's generally a major case of mistrust towards nuclear power, just like we talked about before, because people think that it's dangerous, and so they mistrust people that are pro-nuclear, scientists, politicians. But a lot of times it comes back to the whole feeling of NIMBY, not in my backyard. So it's possible that some people don't want nuclear power, not because they mistrust it or they are afraid of it, but because they don't want a nuclear facility or a waste disposal site near their home. So maybe they would be in favor of it, but not near them. This is an attitude that we're going to talk about a lot, not only with nuclear power, but also with renewable energy. So get used to this NIMBY acronym. Get used to hearing that. Okay, so lastly, fusion. Is this the way of the future? Fusion, like we said, produces no high-level waste. So it's different from fission in that it doesn't have nuclear waste that you have to dispose of. The fuel for fusion, instead of uranium that you have to mine, is hydrogen. Well, we can make hydrogen. We have a lot of that, okay? That's not going to be a problem with radioactivity. Awesome. Well, the problems are it takes very high temperatures, like on the order of millions of degrees, guys. So the problem is we have a hard time housing something that's that high in heat, that high in temperature, okay? So in order to make those atoms fuse together and hold together, we have to be able to contain it. And then when you get to that high of a temperature, you have a phase change. You get to plasma, okay? So we not only have to contain that temperature, but we also have to contain the plasma after it's formed. So we haven't been able to do this yet, but once we are able to, it's probably going to be a really great energy. So, I mean, read up on this. This is really interesting reading. I encourage you to look this up, okay? Oh my goodness, that's it. All right, so I've talked a whole lot. Look at those videos later on, and I will see y'all tomorrow. All right, have a good day, y'all.